Let's go through the code 878, nth magical number. So it gives us an integer a and b, find the nth magic number. So magic number is the number which is divisible by a and b. So we know this magic number, for example, a, b, the first magic number is 2, and the fourth magic number is 6, right? So this is different than the question of ugly number because, for example, this if n equals 7, this is return 10, right? 10 is divisible by 2, and it does say that can only be made from a and b. Um, so let's look at the data range. This kind of n is very big, right? And apparently, we cannot do like a linear solution. So let's look at um, how can we do something like a log operations? If we're thinking about the log, right? What we're thinking is that can we do some binary search? So, so what we need to search? If we do binary search, what do we need to search? So if we can see, we have do some way, um, like like search the counts. So what we can search is that, for example, we can search how many numbers are divisible by A and B. So the counts divisible by A and can also be divisible by B, right? So how can we get these counts? So the way to get the counts is that we count how many, for example, we have a number target. So we'll see how, um, just a smaller when for example, we'll say when in the range from 1 to 1 to t, how many numbers are divisible by a and b? Then that will be um, so the count, how can we say that? Is that the t uh, divided by a. This is how many numbers is divisible by a, right? And how many numbers in this range is divisible by b is t divided by b, right? So how many number of the counts, the numbers can be divided by either a and b, right? That should be plus this one. But there is some commas, right? That is some number, for example, it can um, be divisible by a and in the same time divisible by b, right? So we should minus those kind of comma part. So that will be, so how can we count those kind of comma part? That will just get the lowest common accessor, right? So the counts, which is either can be both divided by b, a and b, should minus this part, LCA, A and B, right? So we need to calculate LCA, right? So this will be the way we count how many numbers in this range, which is divisible by A or divisible by B, right? So if we know this, we can use this way to write a count function. So this is the first thing we want to do. So how can we write LCA? Let's talk about for this kind of, how can we search first? So this is, so we have two search algorithm. Um, for every we'll see for 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 these numbers, magic numbers, right? So we'll see that this is the first segment, and the second segment is 2. The third segment is 3, and then that is the 4 and 5, right? And 6, 7, and 8, 9, 10, 11, right? And 12, 13, and 14, um, 15, right? So we'll see this will be the first one, uh, which is the first magic number. This will be the second, right? And this will be the third. So we are asking whether we need to for any counts, right? So we'll see this part has the same counts, this part has the same counts. Every segment has the same counts. So we should search the first counts which has counts greater equal to n, or last counts smaller to n, right? So we should search the left point or right point. So apparently we can search we should search the left end of these intervals, right? Because if we want to, of course, we can also search the right, but search right, we should search the counts smaller than n. And when we search this 5, we'll get this result +1. It is correct as well, but apparently search the left end of this interval will be much better, right? So let's take another example. For example, we have 2 and 5, okay? 25, right? So this is first segment. The second segment is 2, 3, 2, 3, yeah. And this is 4, and this is 5. And let's use 3 and 5 should much better. 3 and 5. We'll have 1, 2 is the first part, right? And this is 3, 4, and 5, and 6, and 7, 8, 8, right? And we'll have 9, and 10, 11, until 12, right? So let's look at this part. Apparently, we can only search 6, right? Otherwise, if we search 8, uh, we should only can search smaller than and then +1 to get the next one, right? This is the first thing. We should search the left end of the segment or range. Another is thing is that how can we calculate the LCA, right? LCA. We'll see LCA AB should equals A multiplied by B divided by GCD AB, right? So we need to write a GCD function. Okay. So after this analysis, we can write code. So we'll see this result. We need a mod. So we are going to use private final static int MOV equals 1. So we'll see the nth magic number. So we'll see long start equals 1, right? And we should be we see the minimum of A and B multiplied by n will at least have, because be enough, right? Because if we consider even there is between this range, there is no number divisible by b. We'll see for this one, multiplied by n multiplied by mass dot mean a b should have already enough number, right? just consider one number. So we'll search the first number which has count greater equal to n, right? Then we'll write while start plus one smaller than n. We'll have long need equals start plus n minus start divided by 2. So we'll say if get a count, so A, B need, if this is smaller than n, right? Then we need to search to the right part. So we'll have mid start equals mid. And if it is greater equal to n, we should search the left part. We'll have n equals mid, right? So in the end, what we want is if get a count A, B, because we want to search first. So we'll check first, start first, right? Then return int start, right? And then else, because this is always exist, we just return get a count a int in right. So we need a write how function get count. So let's say private int get count int a int b long t, right? So we know this should be t multiplied by a plus t multiplied by b minus the LCM t multiplied by LCM a b, right? So we know the LCM is let's have LCM is int L equals a multiplied by b divided by GCD a b, right? So this is LCM. So we'll just return convert this to int t divided by a plus t divided by b minus t divided by L, right? Then we're going to have private int GCD int A int B. So the ways that we do recursive code, if A equals 0, just return B. Otherwise, just return GCD B mod A in A, right? So this will be the code. And we'll see, we have the time complexity will binary search this kind of end, right? So if this is, for example, it is minimal AB multiplied by N, right? So it is a log operation, and the space is constant, right? So time complexity is log mean AB multiplied by N. And we can also write Python code for this. So we're going to have mod equals 1. So we'll say we def GCD, right, into x x int y int, which this is return int, right? So let's say if x equals 0, return y, let's just return GCD y mod x and x, right? So we also need the get count, right? The count. So we are going to have a target t as unit, right? This is retained. So let's say we're going to have LCM equals we have A and B as do not pass in, right? So will be A multiplied by B divided by GCD A and B, right? Then that will just return T divided by B plus T divided by B plus minus T LCM, right? Then in our main function, we do binary search start n equals 1 and n multiplied by min a b, right? So we'll write while start um, while start smaller plus 1 smaller than n, we're going to have mid equals start plus and divided by 2. In Python, we can just write divided by 2. So if ant mid, if this is smaller than n, then we're going to have start equals mid, and else I have end equals mid, right? So in the end, we just check. Um, so if it count, if count, right? Let's say this is get count, get count. If get count start equals n, just return start. That's just return. Hmm. We should mod, right? Because we didn't use the mod.